I was not on mute that whole time. You guys can hear me back there now? Okay. Okay. Let me know when we're good. Good? All right, so for those of you who don't know me, my name is Shannon Poole. I work at Red Hat on the mobile application platform, but we're not going to be talking about any of that stuff today. We're going to be talking about WebRTC, how it differs from WebSockets, and how you can get started making a very simple video chat application and WebSocket signal server. So first I want to talk a little bit about what WebRTC is. So WebRTC is Web Real-Time Communication API that's available in most modern browsers now. It lets you create a peer-to-peer connection between two users on two different browsers anywhere. So the differences between WebSockets are when you create a WebSocket connection, you are connecting to a server. All the data you send through WebSockets is going to that server, and then that application may pass that on to other people. So you could set up a communication between two people through WebSockets, but there's always that middleman there. With WebRTC, you can set up a direct connection, but you still need someone in the middle to pass information back and forth. It's a bit like trading phone numbers. You need to get the phone number to the person, right? So when you turn on your computer, you open the browser and you go to a URL. It sends a request to the DNS server, gives you an IP, then the browser starts talking through a socket on that IP in some port. If I want to talk directly to another person, I don't know their IP address. They might not necessarily know their IP address because it could be behind a router, firewalls, and so forth. So there might not be a public IP address that they know about. So there are a few ways that WebRTC deals with this. One, three different terms in how WebRTC deals with this issue. So there is the ICE protocol, stun servers, and turn servers. We won't talk too much about turn servers because most cases can be handled without the turn server. So I'll tell you what it does, but we're not going to set one up today because it's basically a middleman and it costs money to run a turn server. So we're not going to do that. So the ICE protocol, basically, when you say to create a connection, you hit one of the ICE servers or a stun server, and the stun server returns back some information about you. So it's IP address, port, some route back to you that you can then pass on to the signal server, which can pass on to someone, and then you can collect a bunch of these, and then the ICE protocol picks the best route between the 2 points, right? So you'll see in my first 1, 2, 3, and then the non-numbered one is the end goal there. And then I also have a client-side HTML page to go with it. So what we're going to do is we're going to set up a basic WebSocket node server. The node server is also going to serve our HTML page just because it's easy enough to put them in the same place. So I will go through that now. So we'll start with step 1. If you could read through this README here, I should probably give you the link to the repo if you want to follow along. Oops, that didn't really make the Chrome part bigger, which is what I wanted to do. I don't know if you guys can see that, but I'm Shannon at GitHub. I managed to get a very simple username. I basically just asked because the person that had it wasn't using it, and they gave it to me. So, yeah. So you can go to Shannon/WebRTC demo. You can get the source code. There's a bit of instructions there to get it started. Basically, just npm install, npm start, and then you'll have it running. In this case, I'm going to be using local tunnel to set up an HTTPS connection, because when you try to use WebRTC or WebSockets in this case, it has to go over SSL or it won't let you connect. You could run this locally on localhost and it would work fine, but the browser prevents you from doing that outside of localhost for security reasons. So we won't go through the setup, but it's basically just npm init, then install these npm modules. So Koa is the modern version of Express. It just uses asynchronous functions instead of having to deal with all the callback middleware and stuff like that. So it's a little bit easier to follow, I think. Koa static just to serve the index page. Koa WebSocket is just to wrap so that we can accept WebSockets. And then kcores is the cores module. When you are sending WebSocket connections and WebRTC, it has to be, the origin has to be accepted by cores or it will fail. What else? Oh, and the other one was this UI. We're going to use this to generate UUIDs. When a person goes to the web page, they'll get a UUID. It's just for passing information back and forth. So those are the modules. The start, Koa static, WebSockify is the Koa WebSockets. You just wrap the app. You add the cores middleware. We serve the public folder. And then this is just a basic WebSocket middleware, which isn't going to do anything yet. We'll get to that in the next step. I just wanted to make sure that we could establish a WebSocket connection to the server. Okay? And then we do app.listen on the web port that's defined. In this case, it's 8080. So we can go ahead and start that up. Oops, I actually don't want to run, that's the finished version. I want to run the non-finished version. Okay? Sorry.
Maybe we could just pull the screen down.
Is it just the bottom? Yeah, it is, huh? Sorry, I'll just make this a little bit smaller. If I could figure out how to. Can you guys, I'm just running node index1.js, so just to start the server. Thank you. Okay. So we started that up, which is now serving all of these index pages, but we're going to go to the first one. So I'm going to load up localhost, and we're going to go to index.1.html. Now, it doesn't look like it did anything, but what I'm going to show you is in the DevTools what it did. So actually, let me show you the code first to make more sense. All I'm doing is establishing a WebSocket connection to localhost, or whatever URL you're on. This this is in the new ES module format, which is why it's written like that, just because I want to get people familiar with this syntax and what it's doing. So you see script type module. It's basically just a module. It didn't really need to be, and it probably won't need to be by the end of this, but I did it just, trying to get used to it. But I did import this adapter JS at the top. So WebRTC has changed a lot over the last couple of years. So this adapter basically shims all of the browsers so that they use the same format for things. It's really just the API is a little bit different. So I just dropped that in there to make my life easier. I just followed the latest standard and dropped that in, and I'm good to go. I don't need to worry about, well, which browser am I in, blah, blah, blah. So this, if you're not familiar, this is an asynchronous function, which basically allows me to do await on it. I could have awaited on the promise, but So you'll see later why I did that, but I'm just returning a promise, and then when the signal connection, the WebSocket connection is open, I'm resolving the promise with the signal connection. So pretty straightforward, but you'll see when I come over here and load this up, you'll see I load the index page, but down here is the WebSocket connection. So we could tell that it's a WebSocket connection because we can click on the WS tab there, and only WebSocket connections show up here. It's not sending any information, but I know that WebSockets worked. I know it connected to the server, and we're good. All right, so the next step will be part 2. So I will load up, actually let's go over it first. I have notes here for the different steps. Step 2. So step 2, we will create a UUID whenever someone connects, and we'll send a welcome message to the client. And then I'm just going to move some things around in the client just because in preparation, so that's why it says restructure into a class. And then I'm also going to add the code for accepting that welcome message and what to do with it. So step 2, pretty straightforward. We import the require the UUID, and then we're also collecting the connections. So every time someone connects, they hit this middleware, and I create a UUID, and I add that UUID to the list of connections, and it's a map, just because it's easier to iterate over. And then on WebSocket close, I delete it from the connection. So if I were to close the connection, I just remove it from the list of connections. And we're going to need a list of all of them so that we can broadcast new people as they come into the web page. And then I'm sending a welcome message, which is basically just a stringified object, welcome with your ID. Say welcome, here's your ID. You'll see that the WebSockify added this CTX WebSocket property. So basically all of the WebSocket endpoints has this WebSocket where you can send and receive information. So that's what the core WebSocket module did for me. And it uses the WS WebSocket module. So I think it's just the WS package on NPM under the hood. So just a wrapper for that. So that's the welcome message. And then we'll go ahead and start that up. Over on the index page to go along with this, I moved the establish signal connection into this app class just to make things a little bit more encapsulated. And then I added this connect function. And what it does is establishes the signal connection. So that's the WebSocket connection. And you'll see I can do await because that's a promise. And normally I would have to do some sort of callback or something like that. But now I can just await it, and it makes my code look more synchronous, even though it is asynchronous. And then I define this on message, which is where I accept my welcome message. And I just set the this.uuid to be the UUID that's passed back to me. So now I know my ID based on what the server gave me. You'll notice that I'm using arrow functions here, and I'll pretty much be using them exclusively so I can do things like this.uuid, which is referring to the class because it goes up the list. Then I don't have to do bind and all that stuff, and self equals this. So if you're not familiar with arrow functions, they're in all modern browsers and modern versions of Node, I think from Node 6 up. But yeah, I say get used to them. It's a little bit cleaner. And then I'm just calling a new app.connect when the page starts. So you'll see now when I load this page, so we'll go to index 2, we'll start seeing some data come across the WebSockets. So we'll see you can click here and you can see frames, and this is all the data that goes back and forth over that WebSocket connection, and we can see the server sent us a welcome UUID object. Okay, and that's step 2. All right.
What does frame represent? Like, what is that?
So frames are it's a networking protocol term. So it's like a bunch of packets are a frame. There's a header and stuff, but you don't have to deal so much with that. You can just do post, basically. It's like send this string and you'll get it on the other end. You don't need to go that low level with it. But the term is called frames, which is why you see that. So step 3. Let me know if I'm going too fast. Oh, we already, that should be connections, not collections. And we did that in step 2, actually. So step 3, we're going to, I'm just going to move this because it's going to bother me. We're going to broadcast on join. So when someone new joins, we're going to tell all the other people that are already connected that this person has joined. And then we're also going to set up and receive relay offers. So an sure, go ahead.
So far, we're only doing website, right?
Yeah, we haven't done WebRTC, but we're going to start accepting offers, which are WebRTC offers. So when you set up a connection, you're going to give it a list of ICE servers, and then it gives you a candidate. You create an offer, and you send it to the person. And then the person takes that offer and sets the remote connection, and they start generating candidates, and they start passing information back and forth. So the very first step is called an offer. You say, I would like to connect to you. Here's my information. So that's the very first step we'll do in step 3, and then we'll do the answers and candidates in step 4. So the client, we're going to receive broadcasted joins. So when someone joins, I'm going to now send them an offer, right? Because the person that joined, it makes more sense for everyone that's already in the room to connect to them rather than them to connect to everyone in the room. It makes more sense to me anyways. I'm not really sure whether it really does, but that's how we're going to do it. We're going to create the peer connection, and we're going to create and send the offer. Okay. So step 3. Did we do step 3 already? No. Basically, step 3, all we did was add this on message. So this is to set up. This will be when someone creates and sends an offer to the signaling server. We're going to take it, and based on who they say to send it to, so the new person, we're going to go through the list of connections and send it to that person. And then they kind of start the connection. And then down at the bottom, this last bit here, just tell all the existing connections about this new connection. So we loop over the connections map, and if it's not this connection, send it to everyone else. We just don't want to, that's why there's that little and there. And then, okay, so part 3 of the index page, actually let's start that server. So you start to see some WebRTC stuff. So we got our list of ICE servers up in the top. There are a bunch of public non-production use stun servers. You can find them just by Googling. I'm just using the ones that Google has. You really shouldn't be running your production code through it because I don't think it's really guaranteed to be there. But in this case, there's no. There are open source turn and stun servers that you can run. CoTurn is a popular one. You can run yourself, and then you could just use your own endpoints there. But I think the idea is to put a lot of them in there in case one of them doesn't respond, then it can go through the list. So you might want to choose from a bunch of different ones. So that's our ICE servers, and then we'll see we've added a second set of case statements. So we're going to basically do the same thing on join as we do on offer. So a join is when someone else joins. We're going to establish a connection to them. And then on the other end, the person that joined is going to get the offer, and then they're going to establish a connection to me, right? So that you both have to do it on both sides, which is why they are in the same break statement there, case statement. So we'll go down to this establish peer connection. So we need to know who it was from. And this SDP is, it's the description, it's the offer, basically. So it's the WebRTC connection description. I'm not sure what STP stands for. I didn't think to look it up beforehand. So you'll see down below, it might not be defined when someone joins because they don't have an offer, but we're going to do a little bit of logic there just to make sure we handle that. So let's see, down here in establish peer connection. The first thing I do is create the peer connection. So I'll come back up after this. So creating a peer connection. This RTC peer connection is the API that's in the browser, right? So that's not my code. That's the API that you would use, and the adapter has shimmed it. So all we're gonna do is pass it the list of ICE servers, and now we have a connection to work with. And you'll see that I'm just binding to the different states. I'm not doing anything with them other than debugging them so that we can see them. So I do on negotiation needed, debug, debug, debug. So if we look over, actually I'll do that after I explain this. So an important part here is on ICE candidate. So we gave it a list of ICE servers, and we're going to send that, we're going to create an offer and send it to the other person. But in parallel, it's going to start going through the list and finding ICE candidates to use, right? So we want to bind to that event, and then as we get candidates, also send those to the other person, right? So we're sending them an offer and candidates. And then we have the signal channel, which was defined I'm setting up a data channel here. So this is a WebRTC data channel, so that in the future, we could actually do the signaling over the WebRTC connection. So reasons you might want to do that would be like upgrading from a data only to a video and audio. You don't have to then go back to the server to transfer information because you've already got a direct connection that you can then exchange information about. So you can create a whole new connection based on that. So then it becomes like self-bootstrapping, which I just put it in there just to show you guys that we're not actually going to use it today. Then I just add the new peer connection to the list of peers in the class so that I can reference them later by ID. So now we're back up here. So we've created the peer connection, and yeah. Then we're actually going to listen for the signal channel, that data channel that I said, to open. And when it opens, we know that we've established a connection. So in this case, I'm just using it to know that the connection is good, and that's when I resolve my promise for establishing the peer connection. There are other ways to do it, but I found that trying to pay attention to the state, things can be in flux sometimes, and it's a bit tricky, and this was the simplest way for me to do it, is just listen for that, because it won't open until everything is stable, right? So, so that's how I know that my connection is open, and then when the connection closes, I delete it from the list of peers. So when that person drops off and the signal channel closes, I know they're gone. Okay. So remember I said that we're going from join and offers. So the second argument there in the function is offer. If there's an offer, I'm going to create an answer and send it back to them. If there is no offer, then I'm the one establishing the connection, so I create an offer and send it back to them. So instead of sending an answer, I'm sending the first offer, right? That's really the only difference between the two scenarios. Everything else should be the same. So I create my offer or answer, and I set my local description. So that's me. I'm creating the offer, but now I'm setting that peer connection, the local description, to be that value so that I can start generating ICE candidates, right? And then sending them ICE candidates. So then I send through the signal, which was the WebSocket. This is the WebSocket connection. I'm sending to this person, this SDP type answer offer and the actual description value. Okay. Any questions on that? I know it's a bit confusing. Go ahead.
Sorry, is it correct to say that when that promise resolves, send will be processed after that?
No, the send will go out before the promise resolves.
So this is really...
Yeah. So this is still a callback here, even though I'm using await and other things in some place. The event listener is still a callback, so it's still happening event-driven and still resolving later.
But essentially you're firing off 3 different tasks.
Yes. Yep.
No necessarily
Exactly. Yep. And then, but it will not establish. So if we go up here, and the reason I did this, so this will basically wait. It'll block here in the execution of this block of code, but it's asynchronous, so it's not blocking anything. It's not blocking the UI thread or anything. But until we're done exchanging ICE candidates, and until we have an actual connection, it'll stay right there, right? Which is nice.
It's not like a call or continuation.
Yes. Yep. So let's see what that looks like. So again, I'm not doing anything UI-wise. I'm just paying attention to. Oh, I need to open a new browser now because it's waiting for connections, right? So I'm just going to open up a new tab. And then you'll see we started to send information back and forth. So if I open the other, sorry, I don't normally work on a Mac, so I forget all the shortcut keys. And of course, I didn't record the network, so the next step I'll show you. But anyways, we got the join. So this is the new person. So I'm, make this bigger. Can't make that bigger. Can you guys see this okay? I don't know if I can make the DevTools any bigger. Oh yeah, I can, okay. So I'm 8EF, and the person connecting is 2CE. So, and then once they connect, I send them an offer, and I send them, so the green is me sending them, and white is me receiving. So I start sending them candidates. We haven't done the other side of it yet, so they're not sending me an answer yet, right? And then the next step, you'll see it coming back. I'm not sure if I logged. Oh, I need to turn on verbose because I did it as debug. You can actually see the different states that it went through based on my debugging that I did. You'll see it did negotiation needed, signaling state change, gathering state change, and then ICE candidates start to come in. On ICE candidate null means it's done. It doesn't have any more to choose from, and that's how you can tell when it's done. And that's another part of why I did on the data channel, because instead of trying to figure out based on null whether it was finished and if the other side's finished, I just figured I'd wait till the channel opened.
So with more than 3 possible candidates.
Yes. So it's gonna give. So that's what the ICE protocol does. You give it a bunch of possible routes to you from that person, and they both decide on the best one.
Right, but they only sends 3.
In this case, yes, because that's all the ICE server. Well, it might start sending more. No, I think it's done. No, it's done. It's going to depend on what I put in this list. So it can only find 3 possible candidates. The other 2, yeah, I'm not sure why. It depends on the stun server, the network. I'm behind a firewall. There's lots of different reasons, but it found 3 viable candidates, and it's going to send them. Okay. Step 4. Yeah. So we're going to set up to receive and relay answers, receive and relay candidates, and then the server side, the signal server is done after we do that. And then the rest is all client side. And then a client, we're going to send the candidates, receive offer, create and send answer. Okay. So step 4. We've basically just added a little bit here. Yeah, it's just the one line. Well, 2 lines. We're just adding offer and candidate, because all the signal server is doing is trading information back and forth. It doesn't care what that information is. It just needs to know who it goes to. And then everything else happens to fit in. It's off the page here, but fit within this. It's got a type, it's got an SDP, and it's got a from and a to. And that's really all we care about. And that's it for the server. So I'm going to run the main server now, which is just under npm start. Okay. And then we'll look at this. So this is all the same, but we've added a few breaks here. One is on candidate. We add it to the, so I'm getting the peer connection from the list of connections because I might have more than one. So based on the message.from, which is their UUID, and I'm adding the ICE candidate as they come in. So in that scenario, because of the way this is asynchronous, the first block is still waiting there, and I'm now adding candidates, right? So it's come back around and a second on message call, right? Does that make sense? Yeah. And then on answer, I'm going to do the same thing. I set the, so on answer, you set the remote description, right? So that would be, I'm setting the description of the other side of the connection. So they've now gone through the list and they figured out this is the endpoint that we're going to use. Here's my answer. And you set that up and you establish the connection. So we can look down here. Create answer, create offer. Yep. So in the first step, if there was an offer, I'm setting the remote description to what they offered me, right? So if they sent me an offer, I'm setting my remote description to that offer, and then I'm generating a new local description. And then we're going to go through the list. Then they go through the list and it creates an answer. And that's why this is asynchronous, because it might not necessarily happen on the next line. It's going to happen after all the candidates are done traveling back and forth, right? Okay. And I think that's it for establishing a connection. So we'll load that up. So we got a new page. I think that might have been a little tricky because there was already a user connected, but I'm just hoping this won't be too messy for us to decipher what's going on here. So anyways, you can see the welcome message, the join, the new person. The IDs are random, so they're going to change. We got a 2. We start sending candidates, and then they sent us an answer. The candidates aren't done yet, but they've already picked a good connection. So on that answer, I can set the connection, and they can still keep going through the list of candidates. And then on the other side, actually you'll see here, the last thing there, data channel connection established. So there's actually a connection between these two browser tabs that we could send data over. We won't do data only, we're going to go straight to video because it's a little bit easier to see. We won't have to keep looking at the dev tools. Okay. I'm not sure on the particulars of the algorithm, but that's what the ICE protocol is doing. I'm not sure. It's something internal, native. You don't need to worry about it. You just give it the list, and they decide. The two browsers decide. So a turn server would come into play if there was no direct route through the stun, right? So if I'm behind a corporate firewall that has something blocked and there is no route back to me, I can create a connection to a turn server, which then gives me a different description or a candidate to then give to the other person. But they're actually connecting to the turn server. So that turn server is now relaying all of the video and audio and data that's going through it, which is why it costs money, because now you have to host a server that can handle that stuff, right? With 1 or 2 people, it's fine, but when you start getting, you wouldn't want to run Hangouts through it all the time, right? Right, so the stun and the turn server are, yeah, so
I understand their alternatives, but if one person connects to 2 and one person connects to 3.
yes. So if they both got to different turn servers,
Yeah.
I believe they would talk to each other. I think that's the point. They are now act as like a mediary for that person that couldn't get out or didn't have a route back to them. You know what I mean?
Yeah.
But if they both have the same list, they should be the same turn server. They should have ended up at the same one because that makes the most sense, right? Because the data doesn't have to go very far if it's on the same server.
Right, yeah.
I would assume that it would pick that as the best option if they both could get to that server. but they might not be able to based on firewalls. They might not be able to reach it at all for whatever reason. You know what I mean? Okay. So normally turn servers require authentication on one side, right? So if I'm going to use a turn server, I need to log in and pay for the amount of bandwidth that I'm using. But I don't think it's both people. It's whoever couldn't get out would have to pay for it, right? If they both can't get out, they both pay for it. Okay, step 5. So server's done. We're going to do a little bit on the client. We're going to capture and output local video and audio stream. So we're going to actually do a media capture and output it onto the page so we can see it. And we're going to add that local stream to the peer connection. So this is all still happening in, oh no, I added a separate way. So it's all still in the connect. So the first thing I do on connect now, and the reason I do this is so that you, in this particular demo, you have to approve your video before you can actually establish a connection, right? So you can't just sit there and watch everyone else. You have to be sending information. Although you could open the console and disconnect the thing if you wanted to, but it's beside the point. So this get local video stream, pretty straightforward. So I've now defined a video tag in the body. It's just a simple tag with an ID, autoplay. If you don't do the autoplay attribute, the first frame will just be frozen, and every time you load the page, it'll be a new frame of view, and it won't continuously play. The muted is important too. You don't want your audio coming back at you. Even if you have headphones on, it will be slightly delayed, and it will drive you crazy. So just mute your own audio. You don't need to hear it anyways. I'm sure there are different ways of dealing with that, noise cancellation and stuff like that, but we're not going to do any of that stuff. It's just going to be straight. So first thing we do in get local video stream is query selector the local video tag, and then we use this navigator.media devices get user media, video and audio are set to true. You don't have to do audio and you don't have to do video. You can do one or the other, but we want both in this scenario, so I'm doing both. And then you just set the source object to the stream. It used to be different. You used to set the source to a URL created from the object, but they've recently updated that, and if you try to do that now, that adapter will tell you that you're using a deprecated way of doing it, and you should switch to doing it this way. That's the good thing about that adapter. It tells you all the deprecated stuff you're doing. You get nice warnings in the console. And that's it. So now we have a local stream. So we're just returning the actual stream object because we're going to use it. So the very first thing during connect, this.local is the local stream. And then during the create peer connection, during the establish peer connection, I didn't name those very well, did I? We're going to go through the tracks of that local stream because there is a video and an audio, and we're going to add it to the peer connection. So if you're not familiar with the for each, it just loops over the array for each arrow function. So track and then pc.add track, and then you have to add the stream, which is so you have to add the track and the stream to the peer connection. Right? And then that's it. So we will start. So you'll at least see my video come up. And there I am. It's not actually coming out on the other end because I'm not doing anything with it on the other end. It's sending it, it's just not attaching it to anything. And that will be the next step. So if we look at, I'm not sure that we can see WebRTC stuff in here. No, we can't. We can't see that it's sending the stream, but just believe me. Okay. So then the last step is taking that stream that I added to the peer connection and all of the remote connections, I want to see them on the page. So output remote audio and video streams, remove remote video when the connection closes, otherwise we just end up with a bunch of frozen people on the screen, And then I'm adding in one line of code to add support for SSL so that you guys can try it with me. Okay. So this is the last step. So you'll see that there is this guy here. So add event listener. So when the peer connection gets a new track from the other side, a receiving track, just run this function down here, add remote video stream. I only want to do the video because I'll get audio and video there, but it's one stream. So it'll loop through twice if I don't do that, and you'll end up with two videos of the same thing. So I only care about the video side because they both have a reference to the stream, and that's what I really care about. You could separate them, and it might make sense to do that depending on your scenario if you want to mute and turn off your camera and mute your audio. We won't do that today, but we could try to do that next time if you wanted to. But yeah, you could have a separate audio tag for your audio track and a video tag for your video track if you wanted to. And then you would just stop and play those depending on what you wanted to do. Or if you wanted to mute someone else, you would do the same thing. You would mute their audio track. So the add remote video stream. So I added just a container here. This is where everyone's going to go. I'm just going to drop them into this, just append child for now. So I get the remote, create a video tag, and I add the peer ID to it so I can remove it later. So I'm adding, you have to prefix it with something because sometimes the IDs start with a number and you can't start an ID with a number, apparently. It doesn't like that. So I just prefixed it with peer. Set it to autoplay, set the source object, and append the child. And then remove happens the same on close. I just remove that video stream, which just deletes the tag from its parent, from its own parent. It just deletes itself from its own parent. Right, so load this up. Oh, let me show you the one line that I added for SSL is right here. I basically just said if I'm already on SSL to add an extra S to WebSocket. So it's WSS is the secure socket WebSocket connection. There's probably a better way to do that, but it's the easiest way to do it. So it's not very readable, but it works. So now if I load up my second terminal here, I load this. So local tunnel is just creating a tunnel from localtunnel.me into my machine. And then if you guys wanted to go to this URL, we should start seeing each other pop up. I can load it up on my phone. Oh, you need to be using, because I'm using modules, you need to be using the latest Chrome. Which everyone should already be on, but updates automatically. Brian wasn't the other night, so. I can switch it if you guys don't want to update. I can switch it to not using the module system. So I see Scott. There's two of me. Oh, you probably want to turn your volume way down too. I don't know how the internet connection's here, so my computer might get tired of sending video. And obviously my CSS could be a lot better. I just put your own camera down in the corner, and then everyone else is just sort of laid out. I see Henry. Is everyone on Cantina? Well, I mean, you're sending your video over whatever your cell phone service is, so if you're not on the Wi-Fi, it might not be working too well. Does it look okay on your guys's? Do I look okay? Yeah. Scott's moving pretty good on mine. You know why, Scott? It's because we're probably on the same network, and the peer-to-peer connection was probably like directly to each other.
We are.
So, and that's part of the ICE protocol is figuring out that we're on the same network, so just connect locally.
So you guys.
I'm going to reload my page here because we're also tunneling through localtunnel.me for the signal connection, for the signal server, and I'm not sure how reliable it is. It's not sending a lot of data over that, but so you guys can see that me and Scott look pretty good together, right? No one else can get in, huh?
Yeah, mine's just showing me.
Are you on the lowest? No, it wouldn't have loaded if you weren't. If you can see yourself, then it loaded. Yeah. All right, well, we can debug it. It could be that. Are you on your cell phone network?
No, I'm on the Wi-Fi.
I had trouble establishing a connection out from behind Cantina Guest. So it could be that. And this is probably where you would need a turn server, right? Because it's the guest network is probably more restricted than the other ones are. Let me see if I can see you connecting. So what I'd like to do is add in a little bit of debugging here. So the cool part is, right, I just shut that down. Are you still running, Scott? Yeah. So I shut the server, I shut the signaling server down, but we're still connected, right? Because there's no more traffic going over that server. It's all peer-to-peer. And now I'm going to start it back up. But should start seeing IDs pop up. So I see 1, 2, 2. So I saw a new person. Still has to transfer information back, so it might take a second. Now I see Scott. I see more people joining, and no one else is joining, huh? So I see 2 Scotts. Is that your phone too? There we go. We got a new person. So it's interesting to me. Yeah. How long it takes to establish a connection. Yeah, I want to mute it. You can't. You can see my phone, but not. It could also just be I'm not doing it in the HTML CSS the right way, and they're just getting off the page. So there's a bit of debugging we could do, but it's functional, somewhat. So I think I didn't do it in this demo, but I think where we could improve this is dealing with drop connections, dealing with the fact that the signal server, once it drops, it doesn't read connect. So if localtunnel.me decides to drop the connection for whatever reason, there's nothing client-side to make it start getting new people that are coming in because I'm no longer connected to the WebSocket server. So I can only connect to the people that I'm already connected to. In that case, I would use a combination of that signal server that we set up through WebRTC, so that if someone else is connected to the WebSockets, we can do both, basically. and also just to reconnect on disconnect and make sure that when local tunnel.me comes back up, we can get back on there. Obviously, the CSS was a mess. You want to lay that out a little bit better, put some spacing in, make sure everyone's the same size. You'll see a lot of letter blocking, so everyone's the same proportions. You notice that when we open it on our phones, we're long and skinny. So I'm not doing anything with the resolution. I'm just outputting it straight to the video tag. Yeah, so you'd want to add some padding to those color. I think that's it. Does anyone have any questions? I'm going to turn my video off. Go ahead. Latency. So the latency is going to be pretty good compared to going through a server, right? Because we're doing a peer-to-peer connection. So it really depends on the scenario, but there's not anything. Let me caveat that. With the signaling, with the data channels through WebRTC, you can set up a UDP-like connection. So you can say reliable or unreliable, and ordered, unordered. That should help with the latency in some scenarios, but that's not going to help with the video. I'm not sure how the browser deals with the video. It might, because you're just adding the track. You're not creating that channel reliably. I'm assuming it's over UDP, but yeah. So it's whatever your latency is peer-to-peer. It's a direct connection. So you mean as far as the browser goes? Yeah, that's going to depend on the browser implementation.
Are we talking second-ish, 100 milliseconds, 10 milliseconds, 20 milliseconds?
I mean, I've never noticed any delay that was that long unless something was clearly not working right. But it seems to be, I mean, here. The initial candidate exchange. So Scott, can you load yours back up? We're going to see how delayed it is if you look at Scott's. So he's just worried about the stack talk right now. Like, we're pretty on the same network, so our network latency is going to be pretty negligible. So if I go 1, 2, 3, how delayed is it?
It's delayed on the projector, I think.
It could be on the projector too. How? I don't know how else to test this.
Basically, if one of the cameras is pointing away from the screen, you can see it the camera.
So the projector is a little bit delayed. I can tell because my mouse is delayed. Here.
Would you timestamp a packet, send it over, and then just share that?
Yeah, I mean, I don't have any of that code. I would have to code that myself, and I don't have any of that written. I mean, you could detect the latency. But again, the video is a little bit more black box. You just set up the streams. You're not really checking that. And then the data channels, you have a little bit more control over. I don't know if everyone knows the differences between TCP and UDP, but so TCP is going to have extra redundancy in to make sure things get there in the order that you send them and make sure they actually get there. UDP sort of fire and forget. It sends the information. It may or may not get there. So in game development, it's important. So you'd want to send particle effects, things like that over UDP because you don't care that they actually get there. It's not game breaking if they don't see a bullet hole or something like that. So the bulk of your data you'd send like that, and then the important things like position, player position, bullet hits, things like that would be sent over TCP. So you just set up two different data channels, one reliable, one unreliable, and you send them that way. And then you receive them the same way on the other end. But yeah. So, and then to send data, you have to stringify it if you want to send. You could send a buffer basically, and a string is a buffer in JavaScript land. So depending on how you want to chunk out your data, usually stringify is okay, but JSON's pretty big, so you might want to break it down and create an array buffer and reuse it and send that over. Yeah, the UUIDs could be cut in half if you sent them as an array versus a string. So that's half your data being sent just to send information. Just one packet has an ID in it, so you're sending double what you need if you don't do it that way, if you just stringify it. So, yeah. Any other questions? Go ahead.
So you're using Poole. What about something like Feather that's intended for real time? It's focused on real time.
So in this case, we're not doing any real-time communication over Koa. I'm not familiar with Feather. There are stacks for EasyRTC is one that probably make things a little bit easier, but I wanted to show how you actually would create a signaling server. Yeah, go ahead.
Is it your understanding that Koa has asynchronous data features?
So it's event. I mean, it's still Node, right? So Koa is very similar to Express in that sense. It's still going to be good at doing lots of concurrent connections, and there's lots of debate about whether that's the best way or not to do it. But I don't. Again, we're not sending any information, any heavy load through the signaling server. It's all peer-to-peer. And then in HTML5 development, your bottleneck's going to be you're already running in one single thread in the client. You're sending information that way, so I don't think the server is really going to play too much here. But yeah, everything was written to be on the server side. There's nothing blocking here. It's all just create a UUID, which I guess is probably the biggest blocker because it has to run some hash functions, some random crypto. But it's only doing it when a person joins. It doesn't have to do it again. Yeah. Go ahead.
If you were going to add like a Shannon server to this, and you had, I don't know, I work with a lot of schools, and school firewalls are ridiculous, and you want to be able to have them peer-to-peer, not necessarily sending video, just like data packets back and forth.
Yep.
For just data packets, you need to worry about for just data packets, you need to worry about the security and stuff you have to figure out there, and kind of what would you change?
So it's all encrypted. It's all encrypted by default. You don't have to do anything. All the data sent over is encrypted. In terms of security, you'd have to put the turn server outside of the network, right? Because otherwise, you're in the same problem. Unless it has to be accessible, from the outside. Otherwise, you're just putting another person behind the firewall. In terms of security, I think it's pretty. The security risk is pretty minimal, right? Because you're making a connection to a turn server. It's encrypted. Once that connection drops, they can't get back at you, right? So that's the whole point, right? You have this open socket connection that's sending information, and once you drop the connection, there's no way for them to get back, right? So, and again, I believe it's over SSL, which I think that's why you need to have the SSL set up under the hood. So. Actually, it's probably not because there's no certificate exchange in the candidate, but I know it's encrypted. I just don't know what form it's using for encryption.
And you think code turn is a reasonable solution for this?
Yeah, I mean, I haven't set one up personally, but from what I read of the documentation, it looked pretty straightforward. You just run and then personally, I would just run it in a Docker container. Just run, it's one command to get it up and running, and then you just got to just put it on a server somewhere. So it'd just be Docker run, open the ports, coturn, and you're probably good to go.
Cool.
So the turn server, most turn servers are going to have the stun functionality there, right? So you could add those to your list, and in most cases, it's going to pick the stun if it can, and if it can, it's going to pick the turn side of things. So in most cases, if you're not behind a firewall, you're going to be using the stun of the same server. So yeah. Yeah.
Penetrates some firewalls, right?
What's that?
Stun penetrates some firewalls?
Yeah, so my understanding is when I send out a connection to a server, right, so to the stun server, there's going to be a route back to me, and based on my firewall settings and my router, that route might stay open for a certain period of time. And then in case that's the route it can use to connect to me. Once the connection is established, it's permanent, right, until it's dropped. So in corporate firewalls or more advanced firewalls, it's not going to keep that open. So once you drop the connection, it's gone completely and you can't reuse it.
So you're more likely to succeed with home to home than with any home business or business to business.
Yeah, so in this case, I connected to the Cantina official Wi-Fi. You guys are all connected to the Cantina guest. We're still able to communicate to each other without the turn server. So I assume most consumer routers and stuff like that are going to be okay. Yeah. I could be completely wrong on my understanding of that, but that's how I think it works. I do know that there are settings on a lot of home routers where you can set up that feature where it's like port knocking, but the opposite. Like you could say, when I send the signal, leave this port open. So it comes into play with like Steam games and stuff like that. So you're running a dedicated server and you want it to be able to run on this port. So it does that for you and opens it up. In most cases, you don't need to open a port, but in some cases you do, depending on your router. And I think that's the scenario that's in play here. So, good. Anything else? All right. So next month, I'm not sure if we want to take this app and maybe build something else with it, add in the muting, the video, or we can maybe we can make a multiplayer game that sends information over the data channel. We could create a simple chat app, whatever you guys want to do. Now that we have the connection, sending information to each other is easy. And the game that we made with the last couple months with the shooter, we could now make that multiplayer if we wanted to and have everyone join with little triangles and run around and shoot at each other. Pretty straightforward to do that. Yeah, okay. Well, thanks everyone.